Okay, now we are going to talk about the disadvantages of this technique. First of all, this is an outplace algorithm, which means it it sorting and sorting is done by using an auxiliary array, which means it's required a lot of memory for implementing this technique, rather than insertion sort and selection sort is do it by in place, so they don't have this kind of overhead. Therefore this extra space is actually an overhead for this technique. For example, if I have values like 10 to the power 8, so my array size will be 10 to the power 8 plus 1, and the fill up indexes in B will be 5, 1, 6, 8, 3 and 10 to the power 8. The rest of the spaces will be a west of uh, west. So we are going to generate a huge array where a lot of empty spaces. So this is not really efficient. So for applying this technique, we have to be careful when with the values that are present in my sequence. So if the sequence are similar kind of values in a specific range, they are closer to each other, so we can make this overhead not a problem. But if the values are very separated and the distance values, so the waste of space will be a huge burden. Another issue is that the indexes of an array are integers, so my keys should be always integers. To mapping any value rather than integers, we have to like set a previously uh, so basically we have to make an mapping technique here before applying this key index, so key indexing, so it will have an extra work need to be done because we are having only integer as keys, and these keys should be always unique because otherwise we cannot do it accordingly to the indexes in my auxiliary B. Now the extension of this problem is what happens if I have duplicate values. From in our previous example we just saw unique positive values here. So what if we have duplicate values? This can be done using this technique, or can we solve this uh, kind of sequence? The answer is yes. And how we are going to do this? The keys are unique, but the counting itself are more than one. So what we can do is just instead of having one, we are going to have and value as 2 when we have more than one time a value, or 3 and so on. For example, here we have 5 2 times, so my index 5 will contain 2 instead of 1. Similarly, 1 has appeared 2 times, so it will have 2 as its value, not 1 like previously we have for 6 and 8 is showing, and so on. So what we can do is that increment the index of B like previous value plus 1 to solve the problem of duplicates. This can be one of the technique to allowing duplicate values. Another problem is if that can be done using negative values. Is that possible if I have this kind of sequence 5 minus 1 3 2 8 minus 5, and it can be done? The answer is yes again. So what we have to do is just do a simple mapping. The mapping consists of, we are going to find out the maximum value in absolute terms in this sequence given, which is the maximum value, is 8, right? So the size of the array will be double of this maximum value. So it will be max into 2 plus 1. This will be my array capacity. So let's look at this example. Okay, so we created my array B, which has the capacity as a double of the maximum value in terms, absolute terms. So we have from 0 to 16 values. So how we are going to map these values? So the technique is shifting the negative values to the positive one. So how the shifting technique works? We have to add the maximum value which we found as in absolute terms to the actual value. So here is the mapping process. So for example, my first value is 5, so we are going to add the maximum value with 5, which is 13. That means my actual index for the value 5 will be represented by 13. So 13 will have 1. For minus 1, we'll have minus 1 plus 8, which is 7. So the index 7 will be used for the value minus 1. For 3, the value will be 11. We'll have a 11. For 2, the index will be 10. We filled up with the 10. For index 8, it will be 16, which is the maximum value. That's why we took the max, the maximum into 2, so that we can arrange minus 8 and as well as positive 8. For minus 5, it will have the index as 3. So when we search the value, we also look into the mapped value, and we have to deduct the maximum value to retrieve the current or the actual value. So this can be one of the techniques to apply this key indexing to the negative values. Here I have another example where we have the same process, where I have the minus 8 value to show exactly how these techniques work. So if you look into this, the maximum is minus 8, in absolute terms is 8, and we do the similar mapping. So minus 8 plus 8, 0 will represent me the minus 8 values. Okay, that's all about key index searching and sorting technique.